Stop worrying about homework and start learning with confidence. This is Ask Learn. Complete help for every subject. Like, share, subscribe for daily learning videos.
So there are a couple approaches for this problem. Um, let's start with just writing down everything that we're given. We have a mass, m. It is equal to 6.6 times 10 to the minus 27 kilograms. And it's a good idea to keep track of SI units. Make sure we don't need to convert anything. This is in kilograms, which is in units that are SI, so that's good there. We are given the velocity of this traveling mass is 4.4. Times 10 to the fifth. And velocity is given in meters per second, also SI units. Don't need to convert anything there. We are given a magnetic field that this particle is in, B, that is equal to 0.75 Tesla. That's also SI unit for magnetic field, so we don't need to change anything. And lastly, we're given a radius. This particle, this mass, is traveling in a circle, so we are given a radius, little r. Now this is 0.012, and this is in meters, also SI units. That's good. We don't need to change anything right off the bat. So now, another point to note before we start doing any of the math for this problem is that everything that we're given has two significant figures. So that's what we'll want to keep all of our answers to. We'll want to have two significant figures. So now, as I said at the beginning, there are two approaches to this problem. One of them is a little bit more complicated. Let's write out the equations that we have. So we have that the force, the centripetal force, F sub c, is equal to, this is mass times velocity squared, divided by the radius. Now, centripetal force is the force that keeps it traveling in a circle. If there was no centripetal force, it would just fly off straight instead of continuing to travel in a circular motion. That's what this force is. And we know that this is caused by this magnetic field. So this F sub c, is the same F used in the magnetic force equation. I'm just going to write it F sub c. You could write it as F sub b. But since they are the same thing, I'm just going to use the same notation here. So we have this other equation. F sub c is equal to B, which is the magnetic field, times the charge, times the speed that it's traveling at, the velocity. You might have seen this in another form, whereas it's solved for B instead. That's just simple algebra moving this equation around. If you wanted to write it in that form, you'd keep the B on this side and divide both sides by QV. That would give you in the form B is equal to FC divided by QV. So these are the two equations that we have. The harder method would be to look at it and we see that we have everything we need to calculate this centripetal force here. We can go through and plug in all the numbers and find this force and then the physics of this problem is to equate this F with this F and know that they are the same force. It's the force that's causing it to stay in circular motion. The easier way to do this is we can write that if these F's are equal to each other, we can simply just write the two equations equal to each other and do algebra and make it a little bit easier. So these two F's are equal, which means the right-hand side of the equations are equal to each other. So we have mv squared divided by r is equal to the other right-hand side, bqv, magnetic field times charge times velocity. Now, I know algebra can be a little scary sometimes, but this saves us from having to plug in all of these numbers twice. And since some of these are really big or really small numbers, it can get really cumbersome, and it saves on possibly making an arithmetic mistake. So now we can make this a lot nicer by eliminating some things here. So we see that this v will cancel with this. And then all we're left with now, we'll just divide both sides here. What we're trying to find is q. So we'll divide this b out. So this equation turns into, I'm going to flip it around now and write q because that's what we just solved for on the left-hand side, which doesn't change anything in the equation. I'm just flipping it around. Q, we've divided by b, is equal to m divided by r b. And another point, this was a velocity squared. This, since we divided by this velocity, it only canceled out the square, so we still have a velocity in the numerator here. Now, this is much simpler to plug into than doing this and then doing this. Now we just have one equation. So we can plug in these numbers and solve for the charge. So what we get, we plug in the mass, the 6.6 times 10 to the minus 27th. For m, we have the velocity, we have the radius, and we have the magnetic field. That gives you a charge. And we know these are all in SI units, so this will come out to be in coulombs. We get a factor of 3.2 times 10 to the minus 19th. This is in coulombs. We know that an electron is 1.6 times 10 to the minus 19th, rather. And this is exactly double that. So it's exactly 2 times the charge of an electron, or a plus in front of that, just basically because electron and protons share the same charge. That's just basically talking about a proton. So it's twice the charge of a proton. So we have, for our final answer, Q is equal to, we'll write a plus just to indicate that it's a proton, because electrons have negative charge. This is equal to twice the charge of an electron. And there you have it.